Again, I said we cannot do products or quotients. So with product, I showed you just expand it, collect like terms, and then you can do each term separately. Here I'm going to show you what to do when it looks like a division, because I haven't given you the rule. And this is still a good rule even when I do show you the quotient rule later on. It's still a good rule. So it's not one of the ones where it's like, oh, now you're going to show me a better way. No, this is still a good way. Right? This is still going to be a way where I would, sometimes you'd be like one way is better than the other, but this is not a throwaway method, right? So this is actually good. So if I had 4 over x cubed, you cannot do this question because it's division. So you have to change it to 4x to the negative 3. That's all. So when we were changing on the other page, we were changing it from a negative to a positive. I want you to undo it. Right, so I want you to change it back to 4x to negative 3. Yes, I can do this. This follows the rules that I have, which has got an exponent that'll go down and subtract 1 from it. So this one I can do. I cannot do it when it's in quotient form. So it has to be in multiplication form, not quotient form. Okay, so this quotient form doesn't work, but if I change it to multiplication of a negative, that's okay. All right, so multiplication works, not underneath. So this says differentiate using the appropriate notation. We won't always say appropriate notation. We're going to assume you're going to use appropriate notation. But the appropriate notation means if I give you g of x, you're using g of x back. Right? You're not using f of x. If I gave you g of x, it's bad notation. If I give you y, use dy by dx. Here is our hint where we said hint, simplify where possible first. We won't be giving you that hint on an evaluation. We'll assume that you go, oh, wait, maybe I should fix this up before I start this question, right? So that's our hint to you, but it won't be given on an evaluation. So hint not given on evals. Okay, we don't give you a hint like that. But for our notes, we're telling you, hey, what do you think we could do? I want to simplify it a little first. So here, I changed form. Is this the derivative yet? No. You have not accessed any of your calculus brain yet. That was still just simplifying it to a different form. Now you're going to write g prime. I'm emphasizing this because, again, you automatically put g prime and go, oh, shoot, it's the wrong form. If you wrote g prime here, you are not telling me the truth. It's here that it starts. That will be automatically wrong after that. So you have to have this on the right spot, not above it. This was not derivative. Now we're going to do derivative. So now when you do the derivative, the negative 3 goes in front. Negative 12, x to the negative 4. Do we leave it like that? Nope. So we go negative 12 over x to the 4. Okay, you have to leave it with positive. Okay, always positive exponents. So make sure you finish it. So make sure, again, you did derivative on this step, not before. Okay, next one. This one is a little bit long. I should have left more space vertically, so try not to write too big. I am going to not write too big on this one. I'm sorry. I should have left a bit more room. So dy by dx, so normally people go, okay, dy by dx. You can't write it yet. Don't write dy by dx yet, because what I'm going to do first is simplify it, because I can't do division. So division's not allowed yet. So I'm going to divide each one. So I want to divide each one in 1, 2, 3. I'm going to write one extra step here. You don't have to write it, but if you need to, you're going to write x to the 6 over 3x squared minus 6x to the 4 over 3x squared minus 4 over 3x squared. It's like we're breaking it down. We're taking it from lowest common and breaking it back down, right? Then you're going to divide into each one. So again, you don't have to show this step if you don't want to, but I just want to show you what my brain was thinking. So equals. Now, what I want to do is I want to keep the number in front. Imagine, if you will, there's an invisible 1 here. So I'm going to put it 1/3 there. 1/3. And this is x to the 6 minus 2, 4. Okay. Minus 6 divided by 3 is a perfect exact 2, so that's good there. And that's x squared. If it doesn't divide perfectly in no decimals, fractions are our friends. 4 over 3, yay. And that's x to the negative 2. Okay? And yes, you can skip from that step to here. You don't have to show me that middle step, but that's my thinking process. And if you want to show it, show it. Okay. Note here. So look here for a sec. Okay. This x is written in the middle of that line. You know now why. We're being picky with this. If you write it on the bottom, it's back in the denominator again. That's right? And in grade 9, you're like, oh, what difference does it make? It makes a huge difference. It's a totally different function, right? So look at this x. It's written in the middle. So it's not about neatness. It's about accuracy. Don't write it looks like beside the denominator, beside the 3, because you're now putting it back in the denominator again. That's a totally different question, right? So you've just moved it back to the middle. To the middle, that one doesn't matter, but here to the middle of that fraction line, not with the 3. If it looks like it's with the 3, it's wrong. All right, so make sure, just be careful there. And now let's do the derivative. So look, no derivative yet. That was just simplifying. Now I'm going to go dy by dx. So this is where I write it. So please, please, please be careful. Now I'm doing the derivative. Now you're accessing your calculus. You haven't done it yet. So now your calculus rule is the 4 goes down in front, so we're going to get 4 over 3. X to the, x is in the middle, to the 3. Minus 4x to the 1. Negative 2 goes in front, plus 8 over 3, and that's x to the negative 3. Okay. Let's fix that so it's positive. So we're going to fix that so it's positive. And, oops, I'm going to write it a little bit smaller because I want to try to get 2 lines in below here. So it equals, so I'm going to get 4 over 3. That's x to the 3 minus 4x. This is plus 8 over 3x cubed. Is that okay? So that's if we just said you don't have to find lowest common. Frequently, though, we'll ask you to finish it off and get lowest common, right? Because it's not a bad thing. It actually makes it more useful in terms of graphing and answering a word problem and stuff. So it's actually a more useful form. If I was to solve this, I would want it over lowest common. So let's practice lowest common. So lowest common denominator would be 3x cubed, yes? So then this one has to be multiplied by. Now, what I like to do is pretend this is all over, right? So you might as well write it with the 4. So then I'm multiplying, so put it all over. Okay, so it's not a separate function, so it's together. And then you're going to multiply this one by x cubed. Is that okay? And this one, I'm going to multiply it, it's over 1. So I need to multiply by 3x cubed. Okay, and that one I don't need anything. So last step. Ready? So equals. All over, and that's 3x cubed. That's my lowest common. Good? The numerator here is going to be 4x to the 6. This numerator here will be minus 12x to the 4 and plus 8. Good? Questions with that? Yes. Sorry? Yeah. Any questions with that? So just make sure you know when we say write it to lowest common denominator, that means finish it off. That's where you stop where it's positive, and then that's where lowest common is. Oh. No, yes?
So it doesn't matter if we put the x cubed in the middle or like on the top for somewhere
Yes, so it can go in the middle or the top, yes. So the question is, the x cubed here, it could be 4x cubed over 3 or 4 over 3 in the middle, x cubed, yes. Yep, both the same, yep. Yeah, yep, so that x cubed could be up with the 4 or in the middle, just make sure it's not with the denominator, yeah. Yeah, yep, good point. Definitely can be on the top. All right, last one here. Here, this one up here. Now, for this one here, we are going to fix the form. So again, we cannot do multiplication. I showed you that on the other page. We cannot do division. No. You cannot do you can't do division, first of all, and also you cannot do the power of a power here, right? We can't do brackets yet. We can't do anything. We have to expand it all out and simplify it first. So our first step here would be to simplify this. So I'm not doing derivative yet. Do not put m prime. And if I start you with a capital M, keep with a capital M. You keep whatever font, whatever function notation I used. So that is capital M, but it's not derivative yet. I'm going to do this. It'll be 81, right? So the 4 goes to each one, and x to the 8. Again, cannot do division. So this will be 81 x to the negative 8. And now you can do the derivative. Okay, so once it is multiplication, you can do any type. M prime at x, keep the capital, will be negative 648. X to the negative 9, would never leave it that way. Negative 648 over x to the 9. There you go. Right, so the only place we wrote the derivative is when we did the derivative, so just be really careful with that. Ready for another one. Now I'm going to try to, this is just showing you kind of the division idea. Now I'm going to show you some with some fun exponents. So again, it doesn't have to be whole numbers, doesn't only have to be integers. Here we've got more fractions to work with. So again, I am not doing the derivative yet. I want to change the form. I can't do division. I like to change this to fraction form. Technically, you don't have to. So I like to do it so 6x to the 1/2. You can leave it as a root as long as you know it's a 1/2. Minus x, and what's the exponent of this one? 1/3. So you don't have to change it as long as you in your brain know it's 1/3. And this will be plus, this will be 1x to the negative 1. Okay, so changed form, have not taken the derivative yet. Now I'm going to do the derivative. Ready? Right, so that's form. Now dy by dx. So remember Leibniz notation. Okay, dy by dx. Okay, Leibniz notation here. Okay, 1/2 times 6 is 3. X to the negative 1/2. We okay? 1/3 goes in front. Negative 1/3. X to the negative 2 over 3. 1 goes in front, minus 1 x to the negative 2. Good. Fix that so it's positive. I'm going to go 3 stays on the top, x to the 1/2, minus 1 stays in the numerator, 3x to the 2/3. Ah, that's making it worse. Trying to make that better. Nope. X to the 2/3, just as bad as before. Minus 1 over x squared. I was trying to make it bigger, but I didn't succeed, so that's a 2/3. All right. Now, so that's a 2/3, sorry about the writing. That's a 1/2, and that's a squared. Okay, you with me? I fixed it 2 times and it still looks bad. So it's 1/3, 1/2, 2/3, and that's a squared. I want lowest common denominator. So lowest common denominator, take the biggest x. That's 1/2, 2/3, so it's x squared. Right, so my lowest common denominator do be x squared, right? So the biggest x. So whatever x is the biggest, that's 1/2, 2/3, that's 2, so 2 is the biggest. Whatever the biggest one is, if it was 4/3, it'd be 4/3, whatever it is. So biggest x. Then I also need a 3. So here. Now, how do we make a 2 from the 1/2? Yeah. How do you do that? In your brains, I want you to subtract. So you're used to doing this with whole numbers. So if I said to you, so think of it like this. If I said the lowest common denominator and I did something like, we'll just use 1 over x to the 4 plus 1 over x to the 6. We know it's x to the 6, right? So lowest common is x to the 6. You go, okay, I need 2 more. How did you get the 2 more? In your brain, you're going 6 minus the 4. You're automatically subtracting. So whatever I did, if I said 3, you'd go 6 minus 3. I need 3 more. If I said 2, you'd go, oh, I need 4 more. What you're automatically doing in your brain is subtracting. You're subtracting the bigger from the smaller. So here, 2 minus 1/2. What's 2 minus 1/2? 2 minus 1/2. Yep. Yeah, so it's 3/2. If you need to, do that on the side a little bit. So it's going to go 2, 2, so 2, so 4, so it's 3/2. So we know you need 3/2. So you're subtracting. It's just you've been doing that automatically in your head with whole numbers all the time. You don't even remember what you're doing. You're subtracting. So it's 2 minus the 1/2. So what do I need? I need a 3, and I need x to the 3/2. So that's a 3x, and it's a 3/2. Okay, do it again. 2, x to the 2, so you've got 2 minus 2/3. 2 minus 2/3, it's over 1, 3, right, gets me 4/3, right? So I need x to the 4/3, x to the 4/3. Okay, so you do it automatically with whole numbers. You're just taking that same skill you have and doing it with fractions, so subtract. I don't need the 3. This one I just need a 3, right? So just a 3, so 3. Good? Can you read it? I know it's small. Okay, so it's 4/3 that we needed here and 2/3. Okay, now our next step is to write it all. This is 3x squared. And that works for anything, with any fraction. You're just subtracting. Okay, and you've been doing it automatically in your head all the time. You just didn't realize what you were doing. You're just subtracting. So 2 minus the 1/2, 2 minus the 2/3, and that's what's left. So now when I write this, my answer here would be 9x to the 3/2, and I don't care if you leave it in radical form or fraction form, up to you, minus x to the 4/3 minus 3. All done. So that is lowest common denominator. Questions with that? Okay. All right. Now, let's try it again. F of x is this. Is there anything I need to simplify first? Any brackets to get rid of brackets? No. Any division? No. So I can go ahead and do the derivative. So this one, I would right away do f prime. I don't have to simplify. If you can't simplify, you're going to go right to f prime. So the rule is the number goes in front. So 3, the number goes in front, times root 5, x to the, and make sure your root stops above the x, doesn't go on top of the x, and make sure that if it's supposed to go on top of the x, you make it go on top of the x. Some people are still writing it funny, like you're doing, if it's supposed to be square root of 2x minus 3, you're doing this And you're like, yeah, the 3's under, those mean separate things, right? So it's either all over or not over. It has to mean this. So here, the root's only over the 5, not the x. So make sure it doesn't drag over the x. Okay, so it stops above the 5. X to the, and this is going to be what? What's root 5 minus 1? Yes, we just write root 5 minus 1. I sometimes get funny answers for this, but you go like 4. No, it's not root 4. So root 5 minus 1 is just root 5 minus 1. Okay, I get funny answers with that because you start to subtract in your head. So just make sure root 5 minus 1 is just root 5 minus 1. And no, you can't simplify that, but that is a beautiful radical. That is beautiful. That's how we left our radical answers in the past. It was fine. Root 5 minus 1 is your exponent. It's gorgeous. Okay, here, what's the next one going to be? Minus. Anyone thinking minus 14? No, not thinking that because there's no x, right? That's a constant. So this is a constant number here. Good, so it's 0. Good, good, good. Right, does that make sense? So it's no variable. So that's a constant. So I'm just going to highlight that. It's a constant. There's no x. Right? There's no variable, so it's just 0. And then the next one is how much?
6 pi.
That's it, plus 6 pi. Because the 1 goes down in front, multiplies with the 6 pi, x becomes 0, and it's gone. Okay? I throw that in after we do the harder ones because sometimes you're like, oh, I'm not watching carefully. Make sure you don't assume there's an x there. Frequently, I get a lot of people who assume there's an x there. You're visualizing it. You're kind of auto-correcting it. Okay? So just go no x. That is just a constant. There's an x. Okay? So don't auto-correct. I get a common mistake is that you fix things too fast in your head. Good? All right.